All right. Hey, y'all. My name is Kent Haynes. I'm a seventh grade math teacher in Hoover, Alabama, and I'm just going to tell you about the first lesson in my unit on angle relationships. So, the idea here is to just kind of walk you through one full lesson in my classroom, kind of tell you what decisions I made and why, so that frankly, people can argue about if it's good teaching or how it could be better. And I'm just really curious to hear what people think. So, um, this is the first day of angle relationships, just for context. My students are seventh graders. The last time that they really spent time on angles was in fourth grade, which was also the first year that students went home for COVID. So I don't really know what they're coming to class with in terms of prior knowledge. And so a lot of my decisions are built around that idea of seeing what they know and sort of making sure we're all on firm ground in terms of basic vocabulary and terminology. So let me show you what I did in my class. All right. So the first thing I did as a warm up is I got this card sort, which has 16 different angles. I believe I got this from Illustrative Mathematics, which has just all sorts of excellent tasks for teachers in middle school. I cannot recommend highly enough Illustrative Mathematics. They do great stuff. So I basically just gave this to my students and said, cut out all 16 with a partner, and then between your two desks, lay them out from least to greatest. And I didn't say anything more than that. I just wanted to see what they could do. So they spent about 3 minutes doing that, and then we started talking about it. And there were a couple things in particular that I really liked. A lot of my students brought up terminology, acute angle, right angle, 90 degrees, obtuse angle, that sort of thing. And something that I really liked about the angles in this is that there are multiple, first of all, there's multiple right angles. And so we got to have a conversation that, angle A and angle F have the same measure, even though angle F's sides are longer, because the length of the sides doesn't really determine anything about the angle. And you also had a couple of angles. I don't recall which ones exactly, but let's take C and D. It's a little hard to tell which of those angles has a greater measure just from looking at them. But they realized that if you held the two angles up to each other and kind of looked through the paper at the up at one of the fluorescent lights, you could kind of see through one of the pieces of paper and check which one had a greater measure. And I thought that was a really great idea, and I just wanted to really see how my students interpreted the relative size of angles. So that was the first thing. And then, once we kind of laid out those, then I talked about which of these are acute angles, which of these are right angles, obtuse angles, and straight angles. And most of my students weren't really confident with the terminology of straight angle, but they did feel good about the first three, which I was very happy about. So then we jumped into getting the notes for the first lesson. So just to let you know, the way that I've been doing notes this year is to create a set of guided notes. I print this, I write the guided notes for the entire unit and print them on sheets of green paper. So it's just really easy to grab your green sheet and write this stuff down. The reason I started doing this is because I realized, I wasn't really we have a textbook that I use for some things, but not constantly, especially not geometry, because frankly, they don't give a lot of good room for the students to work and write and use protractors and rulers and stuff like that. And so they don't have a single resource that they can look to for all of their mathematical vocabulary or, basic procedures, that sort of thing. So I just wanted them to have something that, a week from now they could look at and at least have certain definitions. And so basically I go through and I talk through the notes and they just fill in the blanks. And it's just a way for it to be a little bit more engaging. They just have to figure out, what we're writing down. And I just went through a bunch of terminology and talked about it. So I'll show you my slides for this. And by the way, I'm going to put links to all this stuff so you can view and copy it to your drive or whatever. So let's see. What is an angle? This is a really interesting thing to me because most of the geometric objects that we look at up to this point in middle school are objects that I feel like students can describe very well. They can describe what a circle is, what a line segment is, what a rectangle is. But an angle is sort of this empty space between two line segments or rays or lines. And it's a little bit more of an abstract idea. And so I spend a lot of time talking about this. Now you can see here, it says you can think of it as the portion of a circle between the lines or the segments or rays, right? So I have this animated where the angle shows up first, and then I superimpose the circle on top of it. And I talk about, that looks like a slice of pizza, right? And so the bigger the angle is, the more of the pizza would fit inside there. But we always have that vertex would be at the center of the circle. And then if it was the entire pizza, that would be 360 degrees. If it was half a pizza, that would be 180 degrees. And the reason that we choose 360, and I tell this to the students, is it's very divisible, right? You can divide 360 by 2, by 3, by 4, 5, 6, 8, 9, 10, 12. And so you can get it into a lot of different smaller angles that would still be whole numbers. And I think that's a really cool thing about 360. We just decided that. Mathematicians, somebody decided. There's 360 in a full circle. So we go through the terminology. We talk about straight angles. We talk about right angles. I use the term perpendicular lines. This is a really important one. I realized a couple of years ago my students did not feel very strong with parallel or perpendicular lines. That's vocab that I use all the time, and so I want them to feel very confident with that. And then we talked about, let's see, acute angles, obtuse angles, right? And I'm defining them in terms of their degree measures, right? Less than 90 degrees or between 90 and 180 degrees. And then I think the last thing that we did in the notes was I just gave them this diagram, and I said there's 3 angles that you can see here. And so I taught them like angle terminology, the notation there that you can see, angle ABC. I made them label it in red, and we would actually draw a little red arc. DBC, we would use black, and then ABD, the right angle, we would use blue. And so we talked a little bit about how we have to use that 3-letter sequence to indicate the 3 points of the angle, and that the vertex is always the middle letter, and that sort of thing. And then the last thing that I mentioned was just the term congruent, right? Which is, again, a mathematical piece of terminology and geometry that we use all the time. And I just want them to start feeling confident using that term, congruent. So we took those notes. Not the most exciting part of a lesson, but frankly, especially in geometry, there's just so much important mathematical vocabulary. I mean, I could have even beefed this up. I mentioned in class the difference between a line and a ray and a line segment, but I didn't make them write all the notes down for that. It's something that I just hope they will remember or that sort of thing. But, frankly, I could have made that decision. I'm not sure. Okay, so we did that. And then we talked about how, we're going to learn how to measure angles. And we're going to learn how to measure angles with a protractor, because they feel confident with acute, right, obtuse angles, but they probably, if I gave them a protractor and gave them no support, I'm very confident, especially having seen how the class went, that they would not feel comfortable, measuring these angles. So what I did was I got out my document camera and I got out a protractor, and I showed them how a protractor is, if we go back and we talk about how an angle is the portion of a pizza, that a protractor is just half of a pizza, right? It's 180 degrees, and it goes from 0 to 180. And I showed that it goes, the rainbow of degrees goes in one direction with the outside numbers, the exterior numbers, and the other direction with the interior numbers. And I talked about how you'll see that both of those are important as we go. And then I just drew a random angle and showed them, and I was very didactic, very specific about how they place the protractor at the vertex and line up the line of the protractor with the line of the angle, and talked about that. And I even had them go out from if you were measuring this angle, with the protractor, you would go all the way out to here, and then go up the arc and start counting up 10, 20, 30, 40 until you got to 50 degrees or whatever. And then I just handed out protractors and handed out this sheet that I made last year, where the students just measured angles with a protractor. And the big thing that I really cared about here was, my students every time, first of all, are they placing the protractor correctly? And then when they look, there's two possible numbers that they can use depending on the interior or the exterior numbers of the protractor. Are they using the right one, and are they picking numbers that make sense? Looking at this is clearly to me as a teacher, clearly an obtuse angle. But do they interpret this as an obtuse angle? And if they got, 70 degrees for this angle, would that feel wrong to them? And so what I was doing as they worked was I was looking around first to see if they were placing the protractor correctly, and I would help them with that if they weren't. And then if I saw somebody with a degree measure like 70 degrees, I would say, so 70 degrees, is that an acute angle, a right angle, an obtuse angle? And, they would usually say, oh, it's an acute angle, pardon me. And I would say, so this angle right here is an acute angle. It's less than 90 degrees. And they would look at it and, for the most part, be like, oh, wait, hold up. No, that's not right. And they would get the protractor back out and they would look. And, and that's sort of how I sort of went around and seeded this idea that, you really need to make sure that the number that you're getting off the protractor makes sense with your intuitive understanding of what an acute angle looks like or an obtuse angle looks like. So I had these 5 angles right here, and you'll notice I used, just a bunch of different letters, and I taught them like the measure of angle, KGJ, right? M, angle sign, KGJ equals, and then, how they write the degree measure. And we did that, and then as they flipped to the back, then I gave them a bunch of angle measures to draw. And I thought, okay, well, I'm not going to be didactic about this. I'm going to see if they can do this, because they'll basically get to this in their own time. And a lot of students were able to do it. Some had trouble, but then, I was able to, pull the class together after the students all worked on this and show a couple of examples of how I draw angles. Because frankly, there's probably a lot of different ways, but what I like to do is I just like to start with my vertex and then draw a line going off from that vertex or a ray or what have you. And then set my protractor on that bottom line, which I usually orient along like a horizontal line along the bottom, and then find where my other line needs to go, make a point, and then just connect the dots. So that's what I like to do with that. And we spent some time on that. And then, frankly, it was just about time to go. And so what I did was I had a little, just little sheets of scratch paper. Like I have I snipped like a third of a page off of some worksheet. At some point, I had a bunch of extra ones and I handed them out. And I said, okay, everybody, I need you to put your protractors away. Get out your rulers. And I want you to draw me a 30-degree angle. And that's going to be your exit slip. I will measure them all overnight. And then you'll see who got closest. And so they all just had to estimate a 30-degree angle. And this as an exit slip is really, really important to me because what I want to know is, are my students developing a visual intuition for the size of an angle? Because being able to look at an angle and say, that seems like it's about 30 degrees would be a very, very useful tool, especially an angle specifically like 30 degrees, which comes up so frequently in high school math and beyond, I'm sure. And it's just a very important angle measure. And so I want to see, can they draw a 30-degree angle? And then, the next day, maybe they'll do, 140-degree angle or something. I think that's the one that I did. But anyway, it was really fun. And I got to get out my protractor, at the lunch table, and I was measuring them all and writing the actual degree measures. And, it was pretty cool. I had, one student, and I thought this was really cool, and this will be the last thing I share, drew a 90-degree angle and then attempted to cut it into thirds and then erased all that. And so you could just see the 30-degree angle. And I thought that was just such a clever idea. I also had a student who drew a 90-degree angle, and then attempted to draw a 45-degree angle, and then just estimated a little bit beneath that. They didn't end up getting right at 30, but they got pretty close. And I thought, well, that's very cool. And that shows that they're really building an understanding of what different angles look like and the relationships between them. So yeah, that was my first day. And I'm just curious, first of all, if anybody finds this interesting. Am I doing direct instruction? Am I engaging prior knowledge? Is this student-centered? Is this teacher-centered? I'm being a little sarcastic here, but really, A lot of times I see conversations online about teaching and they feel very ephemeral to me. And I really want to be able to debate and discuss, you know, like what did it look like in this lesson, and what does good questioning look like in the context of this lesson, and not just talking at such a high level that frankly, when I was in my first couple of years of teaching, like that stuff didn't mean anything to me because I was so stressed out about Tuesday. What was I going to teach the next day? And so if you're a seventh grade teacher starting your angle measurements unit, maybe this would be interesting. Anyway, let me know if I should make one about my second day.